Today you'll be learning about solving multi-step equations. Multi-step equations involve more than one operation. These equations can be solved using the properties of equality and the strategy of undoing each operation by working backward. In number theory, multi-step equations are written and solved to understand the relationship between numbers, such as consecutive integers. Multi-step equations include two or more operations. To solve a multi-step equation, undo the operations in reverse order of the order of operations. And I have a hint, to solve a multi-step equation, you can start by moving the numbers farthest from the variable first and continue until you are left with nothing but that variable. You can pause the video here and look at some consecutive integers. Number 1 says 2q plus 11 equals 33. So to solve this, I want to isolate the q. There's a 2 and there's an 11 on the same side as the q. So the farthest from the q is the 11. So since I have plus 11, I'm going to subtract 11 from both sides. When I do, I would get 2q equals 22. So the only thing left, I'm multiplying 2 in the q, so the opposite would be to divide both sides by 2. And I get q equals 11. And you can always check your equations by plugging those back in. So I'll just show you one of them. So if I take what I found for q, which is 11, and plug it back in the original problem, just to check, you'll get 22 plus 11 equals 33, which is true, and it works, so I know that my answer is correct. Number 2 says k plus 9 divided by 12 equals 2. So we have, my pen's messing up a little bit. It's k plus 9 divided by 12 equals 2. So what's farther from k, the 9 or the 12? The 12. So since I'm dividing the 12, I would do the opposite of that and multiply both sides by 12 so that your 12s will cancel out over here and you'd be left with k plus 9 equals 2 times 12 is 24. The only thing left to do, I have k plus 9, the opposite of addition is subtraction. So I'd subtract both sides by 9. And I would get k equals 15. Number 3 is a word problem. It says Susan had a $10 coupon for the purchase of any item. She bought a coat that was on sale for half its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? Write an equation for the problem and then solve the equation. Okay, so she had a $10 coupon. So a $10 coupon, we can say, would take off $10, right? So that would be negative 10. We also had, so that's the coupon right there, $10 off. She also bought a coat that was on sale for half of its original price. So half of the price. So of means multiply half of the price, okay? So we're going to use 1/2 P to signal half price. And we're going to use minus 10 for the $10 coupon. Okay, so we start off with half price coat. Then we take off another $10, and that left her with a total of $125. So this is the equation. So it says write an equation. That's it. Now we have to solve it. So how would we solve it? What's closest to the P, the 1/2 or the negative 10? The negative 10. So I'm going to add 10 to both sides of the equation, and I'm left with 1/2 P equals 135. So how do you solve for P? If I'm dividing by 1/2, that's the same as multiplying by its reciprocal, which is 2/1. So that will cancel out, and I get P equals 135 times 2 is 270. So in your sentence, you can say the original price of the coat was $270. And since she got it for 125, she did pretty well. Number 4 says, write an equation for the following problem, then solve the equation and answer the problem. All right, so this is talking about consecutive integers. So find 3 consecutive integers with a sum of 72. So first you have to know what a consecutive integer is. An integer is like 1, 2, 3, or -5, -4, -3. Consecutive means it's in a row. Okay, so we don't know what these consecutive integers are, but we know what consecutive integers are in general. Okay, so I'm just going to say if it was 1, 2, and 3, which we know it's not because that doesn't give us 72, but just say it was. We don't know what the first number is, so let's just say it's x. We don't know what the second number is, but we know it's 1 more than the first one we started off with. We don't know what the third number is, but we know that it's 2 more than what we started with. So what I'm going to do is I'm going to say, find 3 consecutive integers. So my first integer is x. It says sum, so I'm going to add these together. My second integer is x plus 1. And my third integer is x plus 2. All of those give me a sum of 72. So this is my first. That's my second. And this is my third integer in a row. Okay, so those equal 72. Now, how do you solve that? You just combine like terms. So you have 1x plus 1x plus 1x would give me 3x plus 1 plus 2 is 3. And that equals 72. So now I just have 3x plus 3 equals 72. How do I solve that? I would subtract 3 from both sides. And I'm left with 3x equals 69. Divide both sides by 3. And I would get x equals 23. But that's only one of the integers. So if x equals 23, then x plus 1 equals 24, and x plus 2 would equal 25. So those are my 3 consecutive integers that all add up to 72. And to check, you can add them up and make sure. Now, B says find 3 consecutive odd integers with a sum of 57. Okay, so we don't know what odd integers these are, but just let's say it was 1, 3, and 5. Okay, if x is 1, which we know it's not because that doesn't give us 57, but this works anyway. If x was 1, then the second one, we would have to go x plus 2. Because to get, if you're starting off with 1, to get 3, you have to add 2. If you're starting off with 1, to get 5, you have to add 4. So those are going to be my 3 consecutive odd integers. So I'm going to say x, and it says sum again, so I'm going to say plus x plus 2 plus x plus 4 equals 57. So this is going to be my first, this is going to be my second, and this is going to be my third. So we add all these up. So x plus x is 3x. 2 plus 4 is 6. So 3x plus 6 equals 57. Subtract 6 from both sides. You get 3x equals 51. Divide both sides by 3, and you get x equals 17. So if x equals 17, then x plus 2 equals 19, and x plus 4 equals 21. Those are my three odd consecutive integers that have a sum of 57.